Now refer to question number 8 in the question set. The question asked is, how will you convert this acid, this is diethyl, this acid, to give rise to the aldehyde? Normally, aldehydes can easily be oxidized to the acid by means of some suitable oxidizing agents like permanganate or dichromate or any one of the common oxidizing agents. But it is very difficult to reduce the acids to go back to the aldehydes. It must be done, or it must be affected by means of an indirect method. There are 1 or 2 methods available. We will discuss possibly all the 3 methods that are available. The first method is simply reduce by means of lithium aluminum hydride. This we all know. The lithium aluminum hydride is a very powerful reducing agent, LAH. Normally it is known as LAH, lithium aluminum hydride. So this will get reduced to COOH. Therefore, the product obtained will be C2H5 CH. This alone will get reduced to CH2OH. It will become an alcohol. Now, oxidation of this alcohol to the aldehyde, there is a specific reagent which is known as, I will expand the name of this so that this can be noted down, pyridinium chlorochromate. This is known as pyridinium chlorochromate. And this is a selective oxidizing agent. This is highly selective. Therefore, this oxidizes the CH2OH up to the CHO only. It doesn't go beyond the CHO stage. So it is highly, the oxidation process is highly selective. Now, when we use this PCC, which is pyridinium chlorochromate, this alone becomes a CHO. That is exactly what we want there. So that is going to be C2H5 twice CH CHO. This is one of the methods. Another method will be, this is one method. The other method will be for the conversion. This can be converted to the acid chloride. Convert this to the acid chloride. Then there are a number of methods by means of which acid chloride, SOCl2, PCl5 or any one of the common methods. You convert this to the acid chloride. So this will become C2H5 twice CH. Instead of COOH, this will become COCl, acid chloride. This acid chloride can be reduced by means of a specific reducing agent which is known as, it is not lithium aluminum hydride, but lithium aluminum tributoxyhydride. That is, instead of 4 hydrogens here, 3 are occupied by OBU3. This is OC4H9, tributoxyhydride. This is a selective reducing agent for reduction of, for the conversion of, to give the aldehyde. So this will give rise to the aldehyde, which is exactly our target molecule. So this is another method by means of which this can be affected. There is also a third method. Up to this point it will be common. Namely, you convert this acid to C2H5 twice CH COCl. That is the same thing. After this, you reduce it by means of Rosenman catalyst. Rosenman catalyst is a specific hydrogenation in the presence of, what is Rosenman catalyst? Hydrogen in the presence of barium sulfate or calcium carbonate in the presence of small amount of quinidine as a catalytic poison. The reaction, the reduction stops at the aldehyde stage. It doesn't proceed to the alcohol. So this will give rise to CHO. So this is known as Rosenman reduction, or make use of a Rosenman catalyst, hydrogenation in the presence of a Rosenman catalyst. So this is another method by means of which, so these are all some common methods by means of which the acid can be converted to the acid chloride can be reduced, or the acid can be totally reduced to the alcohol, can be further oxidized to step 2.